I am Don MacAskill. I run SmugMug, which is a popular online photo and video sharing company, and it turns out that I love sushi, thanks in part to Sun, as you'll soon see. We're bootstrapped. We do more than $10 million in sales. It's actually quite a bit higher than that, but we're a small private company, and we now keep our sales figures and everything pretty close to the vest. We're profitable. We have no debt. Again, we are bootstrapped, literally $0 invested in the company. And that's one of the reasons we care so much about technologies like open storage. Every dollar we spend is a dollar that we can't pay our employees. So we like to spend as little as we can in our data centers. We currently have 475 million photos and climbing. That's probably a few million higher since I made this slide yesterday. Those are full resolution off the camera photos, typically, all the way up to 48 megapixels. So as you can imagine, we use an awful lot of storage, both for the binary data itself and all of the related metadata and everything that our customers add. So storage is a big, big deal to us. We do support video as well, all the way up to 1920 by 1080p, as big as your huge flat panel at home that I hope some of you have. Will display, will store, and stream over the net for as many people who want to look at it. Since the first couple of years, we've been doubling every year. We were founded in 2002, so we have strong growth that means we tend to be on the bleeding edge, but luckily to date it hasn't been too unmanageable. Our architecture is LAMP, so we are a Linux shop. I know, don't throw rotten vegetables or whatever you may have brought. But we are mostly AMD, 64-bit, and in our data centers we have hundreds of boxes. It's probably 350 or so, I would guess. We have 4 data centers, 2 of them here in the Valley, 1 in Seattle, 1 in Virginia. And my favorite part about our operations is that we only have 2 ops guys running the whole thing. So all those photos, all that video, lots and lots of customers, and only 2 ops guys. So not only do we care about our costs in terms of capital outlay, how expensive are our disks and everything, but we care about our operational expenses too. We don't want tons of manpower to manage our storage and our servers and things like that. So another reason why open storage is so important to us. Most of our boxes, most of those 350 boxes, don't have any disks internal. They boot stateless Linux, basically, using DHCP off of an NFS mount. And we do, as you may have heard, consume lots of cloud services. Amazon's S3, EC2, and plenty of others. Our storage architecture, our binary data all lives at Amazon S3. So that's more than a petabyte of data up in the cloud today, and it's growing fast, as you can imagine. And we use Akamai as well as other layers internally as caching, but Akamai is our ultimate cache out on the web. So to accelerate all of the requests for serving fast photos and videos. So that's sort of, at least for now, a solved problem for us. Amazon continues to drive their costs down, partly because we bother them to do so. And they're quite fast, especially the way we've architected it. The bit that isn't a solved problem and is an ongoing concern for us is our structured data, in other words, our database tier. It's MySQL, mostly InnoDB. There are a few exceptions, but they're pretty rare. Most of our boxes are fairly high-end, 64 gigs of RAM, 4 or more cores. These days we buy dual quad cores. Our database instances store more than 2 terabytes typically. And then we are heavy users of Memcached. We have, for those of you who are familiar with it, our hit rates are in the high 90s. So we have a big pool of RAM that keeps a lot of our reads off of our database tier entirely. Thanks to Memcached and replication, we mostly care about write latency. Because scaling reads is really easy thanks to MySQL replication and Memcached. Of course, there is that one caveat. We care about data integrity above all. So we want stable, secure data that's super, super fast to write. And one of the big reasons is because we want all of our replicas to stay current. And in MySQL replication, for those of you who might not know, the replica thread is single-threaded, but it's being fed by a master that's multi-threaded. So the writes on the slaves have to happen really, really fast. Otherwise, it gets behind the master and becomes essentially useless. Not only that, but MySQL, in particular, InnoDB, is very concurrency limited. It wasn't written for CPUs with more than one core, let alone the 8 cores that we're currently throwing on it, and the 16 cores we'll throw on it in not too many months. And it wasn't written for high I/O either, basically like a single IDE drive at the time. So we care a whole lot about those problems because they cause us scalability issues. So the faster we can get writes to disk, the quicker we can release those big locks that really slow everything down and keep it from utilizing all of our cores. We care a lot about parallel I/O, as you can imagine. We want to be reading and writing to lots of different tables at the same time. And it's fairly large storage, terabytes, so we can't just buy a whole bunch of SSDs and put all of our data on them yet. SSDs just aren't cheap enough. As you can imagine, that lends itself well to the hybrid storage pools. A big problem for us is that the file system on Linux really, really sucks. But all the file systems that we played with, and we use ext3, but we played with ZFS and XFS and everything, and they all have all kinds of problems. But we have no Solaris experience in-house, and in fact, it's getting to be painfully hard to sort of find and hire developers, let alone sysadmins that have any Solaris experience. So that's a big problem for us. Whereas every developer we talk to has used Linux, they have it on their laptop in college and everything. So ext3 is old and busted. We hate running fsuck because it sucks. The volume management on Linux is really, it functions, but just barely. It's a real pain to set up and administer and use. And of course, in the case of a power outage, if you haven't been really careful about your disks and whether their write cache or their onboard cache and everything is set up, when your system comes back up, it can be in an unknown state. Finally, ext3 does really, really bad on parallel I/O because they serialize writes to each file. So if there's writing going on, then it just queues up and it really, really sucks. So the obvious solution, especially to everybody here, is ZFS. I'm absolutely in love with it and have been for years, obviously because it's transactional, and it's copy on write. We get all of this great end-to-end data integrity with on-the-fly corruption detection and repair. These are big, big issues for a mission-critical data store like ours. We've run into cases where we were pretty sure data was fine on disk because it wrote fine, and the disk and the SATA controller and the CPU and everybody agreed that yes, the write happened and that was great. And then months or years later, there's something wrong, and we don't know when that happened. If the disk had one of those rare errors, or there was a who knows what. Now I don't have to care, thanks to ZFS. The integrated volume management is just unbelievably awesome. Of course, we can quickly do snapshots and clones, and that's important to us for reasons I'll get to in a minute. And we are big fans of open source software. So having our file system be open source is fabulous. But of course, we have a pretty big problem. We are a Linux shop. We have no Solaris expertise whatsoever. No OpenSolaris, no Solaris 10, and ZFS doesn't run on Linux unless you want to do it through Fuse, which of course brings all kinds of problems and basically eliminates the write latency preference we talked about earlier. So crap. So there are 4 obvious solutions. We can try running OpenSolaris. We could convince Sun to GPL ZFS. We could try Nexenta, or we can eat sushi. Running OpenSolaris is the thing I tried first, because it's the lowest hanging fruit. But there really is little to no data about running MySQL, specifically InnoDB, on OpenSolaris or even ZFS for that matter. So the performance characteristics were totally unknown. We didn't know what settings we might need on ZFS or kernel tuning things for OpenSolaris. And these were big sort of unknowns. I've been following the OpenSolaris progress for, I don't know, a year and a half or so, and have heard all of the talks and theories about how OpenSolaris is, learning from Linux and Linux's success and turning OpenSolaris essentially into a more Linux-like Solaris, keeping the awesomeness of ZFS and dtrace and higher concurrency in the kernel, but making it easier for those college students who have only known Linux to adopt and use. So it sounded like a fun project. I managed to carve out some time and gave it a shot. The main question going into it that we had was, can a MySQL slave in replication keep up with our Linux slaves? If the answer was no, I could just stop the experiment immediately and go on to something else. So for the hardware, we took what was then our typical MySQL box, which was a 1U quad-core Opteron with 64 gigs of RAM, directly attached to essentially 30 15K disks with about a gigabyte of battery-backed write cache, and threw OpenSolaris on it and created a Z-pool. We made the MB3000 storage appliances, expose them as JBODs, so that I wasn't using their RAID. Instead, we did software RAID. And it turned out that we, during the experiment, had changed a lot of variables. So we were trying to keep track of everything, to keep stuff as close to an apples-to-apples comparison as we could, but for a variety of reasons, it just wasn't feasible. So of course, we moved from Linux to OpenSolaris. Big jump there. We had to move from MySQL 5 to MySQL 5.1 thanks to some packaging issues and some advice we got from Sun. That's okay, we were planning on making that transition anyway, and so it was not a big deal. The LVM2 plus ext3 to ZFS transition was especially interesting. I didn't know exactly how that would go, and I fell completely in love with Sun's rampant layering violation. ZFS is a breeze, as quite a few of you probably know, to set up mirrored, redundant, reliable pools with hot spares and everything. Taking snapshots and clones is a breeze, and it was just night and day difference from Linux, where it's a real pain and time consuming to set up your storage pool. I talked a little bit about how we set up software RAID rather than hardware, so we were bypassing the RAID controller in the MB3000 so that we could use ZFS to its full effect and sort of get everything else out of the path. And then the geek in me couldn't resist. I decided to turn on compression just to see what sort of performance and ratios we would get. OpenSolaris is supposed to be more Linux-like than Solaris 10. It's certainly not there yet. The user land is downright painful for somebody like me. And it's not that I have no OS other than Linux experience. I use macOS 10 all the time. I used to use SunOS 4, and a little Solaris, FreeBSD, Linux, NextStep, you name it. I have a lot of OS experience. I just don't have time to learn yet another one right now at this stage in my company. The package management was just really bad. It was really difficult to get anything installed. And bear in mind that this was a single-purpose box. All it's going to do is run MySQL. We were sort of thinking, well, if this experiment goes well, we can maybe have our developers use OpenSolaris too. And its user land is not there yet for us to be able to let any other developers use, because they're going to be bothering me all the time to fix their stuff. Packages that we care about were missing. Top and Screen were the big ones. I'm very familiar with PRStat, and I love the tool, but Top is a different tool, and I use both at the same time. And in fact, I keep both running in two different screens, but Screen wasn't installed. I don't know how anybody manages servers without Screen. I certainly can't, so that was a big deal for us. Even something as simple as Apache, when we were thinking about having developers use it, turned out to be a pain to find and install, simply because the package names are something that I can't decipher, and the searching didn't return Apache when I would search for it. I finally found it. It's Sun WAPCH instead of Apache or HTTPD or something useful. OpenSolaris was a RAM hog by default. We're used to giving InnoDB 54 gigs out of our 64 gigs, and that just crashed right out of the gate on OpenSolaris. And so I tuned it down by 1 gig at a time until we found out that we could run it at 40 gigs. It turns out that the ARC was grabbing like 10 gigs and wouldn't let MySQL have it, so that's tunable, I found out. But right out of the gate, it doesn't auto-tune the way we wanted it to. And we run into issues where when I put a really heavy workload on it, it's the bash prompts and stuff aren't interactive anymore. That is a big deal because often you need interactivity when things are falling over the most. And I remember when Linux had these problems, that was extremely painful, but I had forgotten about them. So OpenSolaris brought back all kinds of fun memories. Like I said, I couldn't resist trying compression. It turns out that it works like a charm and it's performant too. I much prefer file system level compression to, say, column level or something in the database, because it provides lots of flexibility on how we adjust it and tune it, and whether we use it on every box that we make a snapshot or clone of and things like that. We tested gzip and LZJB. LZJB was the clear winner. It was really fast. In fact, doing like sort of trying to overload the bus and everything writing to disk, it was faster than with no compression, which we thought was really awesome. We got about a 1.5 times compression ratio on our data set, and fairly low CPU usage. When we were writing as fast as we could to the disks, reading and writing as fast as we could to the disks, it was like 30 or 40% of a quad-core box was chewed up. And that's reading and writing an awful lot more data than we do in a normal workload. gzip was able to compress more, but it completely pegged all 4 CPUs when we ran the same test, and took quite a bit longer. So LZJB, at least for us, is the sweet spot, but if you care about every single little byte, gzip might work. So the conclusion we came to with OpenSolaris is that, especially the file system layer, it was faster and more performant than Linux, like I had hoped. ZFS was awesome to set up and maintain. The management of the pools and taking snapshots and backing stuff up and copying things across the network to other nodes was all unbelievably out of this world. And the data integrity let me sleep better at night than I have in years. But the sort of bad userland experience from a Linux expert rather than a Solaris expert really hampered our decision on whether to deploy it throughout our data center or not. So the bottom line for us is that we were still in love with ZFS, but we weren't so in love with OpenSolaris itself. So we wanted to continue down the checklist and see what else we had available.